Okay, so this is the second part of graphing quadratic functions that are in general form. So remember it's going to be f of x equals ax squared plus bx plus c. And a couple lessons ago, these quadratic functions had, they were in vertex form or standard form. So in this case, they're going to be in general form. So this is continuation of the previous lesson where we did about 3 problems, graphing 3 quadratic functions that were in this form. So we're going to do about 3 more, and then that will complete that lesson. Okay, so let's look at number 1. So let's suppose we had this quadratic function. So let's suppose it was f of x equal 2x squared plus 4x minus 3. Alright, so 2x squared plus 4x minus 3. Just like the last lesson, it is a good idea to go right away, just state what a, b, and c are. So a is 2, b is 4, the coefficient of x is just 4, and c is your constant, so your constant is negative 3. Alright, so remember, first thing we always ask ourselves is this parabola going to open up or down? Well, since a is positive, since a is positive 2, it's positive, it's going to open up. So the parabola opens up. Since a equals 2, which is positive. Okay? Now, once we found that, then the next thing we had to do was find the vertex. So remember, though, this is general form, so we have to use the vertex formula. So the vertex formula is negative b over 2a, that's the x-coordinate of the vertex, and the y-coordinate, once you find the x-coordinate, then to find the y-coordinate, you're gonna substitute that back into your function. So it's going to be f of negative b over 2a, whatever that x-coordinate is. And so to find the x-coordinate of your vertex, you're going to say negative b over 2a, and so b, remember, is 4, so this says I take the opposite of 4, so the opposite of 4 is negative 4, over 2 times a is 2, so I get negative 4 over 4, which is a negative 1. So far the x-coordinate of vertex is a negative 1. Now to find the y-coordinate of the vertex, I'm going to find f of negative 1, so that's what that says. I find f of negative 1. And so I go to my function f, and where we see the variable x, I plug in negative 1. So I get, so that's going to equal 2 times negative 1 squared. So negative 1 squared plus 4 times negative 1, plus 4 times negative 1, and then minus 3. So negative 1 squared is 1. 1 times 2 is 2, so that's 2. This right here is a negative 4. Positive 4 times negative 1 is a negative 4, and then minus 3. 2 subtract 4 is a negative 2, and then subtract 3 gives us a negative 5. So I have so my vertex is negative 1, negative 5. Okay? C was where we found the y-intercept, and the y-intercept, you're always going to have a y-intercept. So every quadratic function, the graph will always cross the y-axis. So to find the y-intercept, though, you let x equal 0. But we talked about this fact before. So if x is 0, remember, if it's in general form, your y-intercept is just as constant. Because if x is 0, this is 0, 4 times 0 is 0, and you're left with negative 3. So your y-intercept is equal to negative 3. So as an ordered pair, you'd say 0, negative 3. Alright, now to find the x-intercept, you let y equal 0. Now first of all, let's make sure there is a y-intercept. So your vertex is negative 1, negative 5, so that's in the third quadrant. Your parabola opens up, so notice it does cross the x-axis. So I am going to get x-intercepts. Oops, x-intercepts. Alright, so to find the x-intercepts, I let my function equal 0. So f of x, which is y, is equal to 0. So I take this, and I set it equal to 0. So 2x squared plus 4x minus 3 equals 0. And then all I do is just plug it back into the quadratic formula, solving this quadratic equation. So I'm just going to plug it back into the quadratic formula. So I get x equals the opposite of b. So remember, a is 2, b is 4, and c is negative 3. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Make sure you're doing all over. So your x-intercepts then will equal the opposite of b. Well, b is 4. The opposite of 4 is negative 4. Plus or minus the square root of b squared, so that's 4 squared, minus 4 times a is 2, and c is negative 3. All over, make sure it looks like this, 2 times a. Alright, so simplifying this, I get negative 4 plus or minus the square root of 4 squared is 16. A negative 4 times 2 is negative 8. Negative 8 times negative 3 is a positive 24. All over 4. And so I get negative 4 plus or minus the square root of, this is going to be 40 over 4. Now, I want to say this. In the chapter, in the lesson that dealt with solving quadratic equations, you did have to simplify the square root of 40. So perfect square that goes into 40 is 4. But all I'm interested here is just finding out what is this x-intercept approximately equal to, so I can plot the point. Leave it at square root of 40 then. Don't simplify this. Leave it square root of 40. In a previous lesson where you were solving a quadratic equation, then yes, you did have to simplify it. But just go ahead right away, since 40 is not a perfect square, this is going to be irrational. So then what you do next is just split this into two solutions. Negative 4 plus the square root of 40 over 4, and then negative 4 minus the square root of 40 over 4. And then you approximate, and those are your x-intercepts. Okay? Those would be your x-intercepts. So on your calculator, now remember I don't have access to the calculator you're using. So remember, on your calculator you're going to say this. You're going to say just like this, just like we did in the previous lesson. So let's take this one for example. You're going to say negative 4 plus, then you press the square root button. Then the open parenthesis shows up. Then you're going to type in 40. Then you're going to close it. Then you're going to enter. And what you get in your calculator, that decimal you get in your calculator will be the numerator. Then you're going to say divide by, in this case 4, then enter again, and that's your x-intercept, or the approximation. Okay, so what you should get is this. Let me go ahead and do that. So 40 square root plus the negative 4 equals, then divide by 4. Okay, if you did this correctly, you should get 0.6. Approximately equals 0.6, nearest 10th. Over here, okay, if you do that correctly in your calculator, you should get, let's see, you should get negative 2.6. Okay, negative 2.6. Make sure that's what you got. Okay, now, so that was D. Okay, E is where you have to find the axis symmetry. So let's go ahead and find E, axis of symmetry. And so it's x equal some number. Remember your vertex, you can look at your vertex for that. Your vertex is negative 1, negative 5. So it's just going to be your x coordinates. So x equal negative 1. And then F, we're going to graph. Alright, so let's see what we get when we graph it. So when you graph this, you're going to get, alright, so you're gonna plot the vertex first. So negative 1, negative 5 is right here. Your y-intercept is negative 3, so that's right here. Your x-intercepts, they're approximately equal to 0.6, so that's about here. And negative 2.6, that's about here, somewhere around here. Then you're going to draw your axis symmetry. It goes to the vertex, something like this. Make sure it's a dotted line. And we want 5 points, so let's go ahead and use this one, the y-intercept. So this is 1 unit from the axis symmetry, so go 1 unit this way. So that would be another point. And let's just connect them, like this. Make sure it looks symmetrical. Do the best you can. Make sure it looks symmetrical. And so there's the graph. Okay? Alright, now, so this was number 1. So that was f of x equal 2x squared plus 4x minus 3. Okay, now the other thing you'd want to you're going to be asked is determine the domain and range. So domain and range. Remember, this is a quadratic function, so it's a parabola. So the domain is going to be from negative infinity to infinity. Notice every one of them, for every quadratic function, the domain was the same. It was all real numbers, negative infinity to infinity. The range was not the same, though. The range depended on whether you had a maximum or minimum. So this is a minimum, so you can go along the y-axis. So it touches the y-axis at, touches the ruler touches the minimum point at the y value of -5, and you're going all the way to infinity. So it's bracket -5 to infinity. All right, and then increasing, decreasing. So where's your function increasing? Where's the function decreasing? Well, remember, you already graph from left to right. So as I go from left to right, my function is decreasing, my y values are decreasing, then all of a sudden they are increasing. But you got to look at the x-axis, you got to look at your domain. So from negative infinity to this axis symmetry at -1, so from negative infinity to -1, my y values are decreasing. And then from -1 to infinity, my y values are increasing. Okay, so increasing from -1 to infinity. So make sure you use open intervals. The only time you're going to use bracket is with the domain and range. And then decreasing from negative infinity to -1. Okay? Alright, so that takes care of number 1. Okay, so let's look at another one. Let's look at number 2. Alright, number 2. Okay, so number 2, let's suppose we had x squared, f of x equal x squared plus 4x plus 8. Let's say we had that. Alright, so a is 1, b is 4, c is 8. And so part A, remember, that's where we determine whether the parabola opens up or down. Since A is positive, A is going to open up, so parabola opens up. Since A equals 1, which is positive. Alright, B, let's find the vertex. So for the vertex, since this is general form, we're going to use the vertex formula, negative b over 2a, comma, f of negative b over 2a. And so the x-coordinate of the vertex is going to be negative b over 2a. So this says I take the opposite of b. Well, b is 4. It becomes negative 4 over 2 times a. A is 1. So I get negative 4 over 2, which is a negative 2. So I found the x-coordinate of my vertex. To find the y-coordinate of the vertex, I'm going to find f of negative 2. So that says I go to my function f, where we see the variable x, I plug in negative 2. So I get negative 2 squared, because that's what this says, negative 2 squared plus 4 times negative 2, and then plus 8. Negative 2 squared is 4. A positive 4 times a negative 2 is a negative 8 plus 8. So 4 and a negative 8 is a negative 4. Negative 4 plus 8 is a positive 4. So I found the vertex. So the vertex is negative 2, 4. C was where we found the y-intercept. So the y-intercept, you're going to let x equals 0. Now remember, this is general form. So by now you should know that if it's general form, your y-intercept is just your constant c. It's just c. It's in this case it's 8. But you may want to go back and just verify. So in place of x, you're going to plug in 0, because that's how you find your y-intercept. You find the y-intercept, you let x be 0. So wherever the graph crosses the y-axis, your x-coordinate is 0. So 0 squared 0, 4 times 0 is 0, and you're left with 8. That's what c is. Alright, so your y-intercept is equal to 8. As an ordered pair, it is 0, 8. Okay, D is where you find the x-intercepts. And so to find the x-intercept, you can let y equal 0. But before you do all that work, using a quadratic formula and all, make sure we do have y-intercepts. So let's think about this. My vertex is negative 2, 4. So negative 2, 4 is in the second quadrant. My parabola opens up, And I want you to notice, does that parabola cross the x-axis? So there's no x-intercepts. So I don't find them. There's none. No x-intercepts. Okay? And then part E is where you want to find the axis of symmetry. So the axis of symmetry. Well, remember the axis of symmetry, we're going to use the vertex, -2, 4. And it turns out that the axis of symmetry is just going to be this x equal this x coordinate right here. So x equal -2. Then we're going to graph. Alright, so when I graph this, I'm going to plot the vertex, which is -2, 4. That's here. The y-intercept is 8, so that's about here. And that's all I have. I don't have any other point. There were no x-intercepts. So what I'm going to do, just like we did in the past, first of all, let me go ahead and draw the axis of symmetry. Go ahead and do that. And so there's the axis of symmetry. And I know that since this is the y-intercept, it's 2 units from the axis of symmetry, then the other point is going to be 2 units this way. And remember, I have 3 points. I need two more points. So what I would do then is just let x be -1. So let x be -1. And then you plug -1 back into your function. So remember, your function was this. F of x equal x squared plus 4x plus 8. That was your function. So where you see the variable x, you're going to plug in -1. And we're going to find out what y is. So y equals -1 squared plus 4 times -1, and then plus 8. -1 squared is 1. 4 times -1 is a -4 plus 8. This is -3 plus 8, which is 5. So I plot the point -1, 5, so that's another point on the graph. So that's this. And then from here, notice from here, I'm going to go 1 unit to the left. And you just graph it, and there you go. There's your graph. You have your 5 points. Okay, that's it. All right, and then finally, you're going to be asked about domain and range. So remember that this is quadratic function, so your domain is going to be all real numbers. Domain, -infinity to infinity. The range. All right, so the range, remember, you're going from bottom up along the y-axis. So as you go along the y-axis, I touch the graph at the minimum. So that's going to be 4 all the way to infinity. So y value is 4. So we bracket 4 to infinity. And then they ask you about increasing, decreasing. That's easy as well. So notice as you go from left to right, your y values are decreasing. So they're decreasing from -infinity to this axis of symmetry, which is -2. That's where it's decreasing. -infinity to -2. Remember though, you always use open circles. You always use parentheses, open intervals for your increasing, decreasing. This is a bracket here. Make sure you use brackets for domain and range. And then it's increasing from -2 to infinity. Your y values are increasing. So from -2 to infinity. Okay, so that was number 2. Let's do one more. Let's look at this one. So this is number 3. Let's suppose my function is this. F of x equal -2x squared minus 4x plus 5, let's say. So -2x squared minus 4x plus 5. So a is -2. A is -2. B is -4. And C is 5. Okay? And so part A is where you talk about whether your parabola opens up or down. Well, since A is negative, the parabola is going to open down. Okay, opens down since A, which equals -2, is negative. Okay, now part B is where you found the vertex. Since this is general form, you're going to use the formula, -b over 2a, comma, f of -b over 2a. Okay, and so the x-coordinate of the vertex then will be -b over 2a. And so this says the opposite of b. Well, b is a -4, Then the opposite of a negative 4 is a positive 4. Over 2 times a is negative 2. So that's 4 divided by negative 4, which is a negative 1. So the x-coordinate of my vertex is a negative 1. To find the y-coordinate of your vertex, remember you're going to say f of negative 1. That's what this says. So if this is negative 1, this will be f of negative 1. So you go to your function, wherever you see the variable x, you plug in negative 1. So this is what you're going to get. You're going to get negative 2 times x is negative 1. Put that in parentheses, but I'm squaring it, minus 4 times x is negative 1, and then plus 5. So negative 1 squared means negative 1 times 1, which is negative 1 times negative 1, which is 1. 1 times negative 2 is a negative 2. A negative 4 times a negative 1 is a positive 4, and then plus 5. So that's 2 plus 5, which is 7. So my vertex is negative 1, 7. C, so remember your vertex negative 1, 7, and it opens down. The parabola opens down. C is where you want to find the y-intercept. To find the y-intercept at x equals 0. But remember, it's in general form, so it's just going to be the constant, and your constant is 5. So my y-intercept is 5. So it's 0, 5, if they ask you to put this as an ordered pair. D, let's find, do we have any x-intercepts? Well, if we do, we're going to let y equal 0. So let's see. So my vertex is negative 1, 7. That's in the second quadrant. My parabola opens down. So yes, I will have x-intercepts. It will cross the x-axis. So we got to find it. So remember, to find it, you're going to set this function equal to, remember f of x is y, so then y is 0. So this has to equal 0. So you get negative 2x squared minus 4x plus 5 equal 0. And remember, a here, just go ahead and rewrite it. So a is negative 2, b is negative 4, c is, so a is negative 2, b is negative 4, c is 5. And the quadratic formula, so now we're going to solve this quadratic equation, so we can use the quadratic formula. And the quadratic formula is the opposite of b, plus or minus the square root of b squared, minus 4ac, all over 2a. Okay, so this says I take the opposite of b. Well, b is a negative 4. The opposite of negative 4 is 4. So remember, these will be your x-intercepts. So 4 plus or minus the square root of b, which is negative 4, squared, minus 4 times a is negative 2, times c, which is 5, all over 2 times a, and that's 2 times negative 2. So I get 4 plus or minus the square root of negative 4 squared is 16. A negative 4 times a negative 2 times a positive 5 is going to be a positive 40, it looks like, over negative 4. Okay? And so this is going to be 4 plus or minus the square root of 56 over negative 4. Now remember, if this was in a section that just said solve this quadratic equation, then yes, you would have to simplify. But we are in the section dealing with graphing, and so let's not worry about simplifying this. We're just going to approximate this. So we are left with the square root of 56. 56 is not a perfect square, so this is going to be an irrational number. Irrational, so you're going to approximate. So we're going to say 4 plus the square root of 56 over negative 4, and approximate what that is. And then we're going to say 4 minus the square root of 56 over negative 4, and approximate what that is. Okay, so in your calculator, the calculator that you're going to use, the one we've been using, here's how you're going to enter it. Let's do the first one. You're going to say 4 plus, press the square root button, the parentheses opens up, you're going to type in 56, close it, and then press enter. Whatever decimal that shows up, that's going to be the numerator. Then you're going to say divide by negative 4, and then press enter. Okay? So let's see, to the nearest tenth, let's see what these x-intercepts are approximate equal to. Okay, so 56 square root plus 4 equals divide by negative 4. The first one here, if you did this correctly, should be negative 2.9. Negative 2.9, approximately equal to negative 2.9 to the nearest tenth. Here, 56 square root negative plus 4 equal, and then divide by negative 4 equal. If you did this correct, this should be a positive 0.9. Okay? All right, so those are your two x-intercepts. Then part E is where you had to find the axis of symmetry. So the axis of symmetry. So remember, you looked at your vertex, and my vertex was negative 1, 7. And the axis of symmetry is a vertical line. You name a vertical line as x equal a number. And it's going to be this number here, the x-coordinate, so negative 1. F is where you graphed. So let's go ahead and graph this. So when I graph this, I'm going to graph the vertex first. So I'm plot the vertex. So negative 1, 7 is here. My y-intercept is 5. And my x-intercepts are approximately equal to negative 2.9 and 0.9. So here is 0.9 right here. Here is negative 2.9 right here, somewhere close to negative 3. Okay, so make sure you see this. Okay, so 0.9 is about here, negative 2.9 is about here. Then we're going to draw the axis of symmetry. Draw the axis of symmetry. And I get this. And use that to help us draw the graph, so that's symmetrical. And remember, you want 4 points. So you have your two x-intercepts, you have your vertex, now your y-intercept. So if this y-intercept is 1 unit from the axis of symmetry, then go 1 unit this way, and you found another point. And then you just connect them, and you're done. That's all you do. Okay, that's all you do. Just make it look symmetrical. Make it look symmetrical. Okay, now you'll be asked to domain and range. Right, domain, range. All right, so remember, domain, this is quadratic functions. Domain is going to be all real numbers from negative infinity to infinity. Your range, remember, is a set of y-coordinates. The arrows are pointing down, so you're going from negative infinity down here, and then you're going to go up and up and up along your y-axis until you get to the y value of 7. So your maximum y value is 7. So your range would be negative infinity to 7 with a, with the bracket. And then increasing, decreasing. So as you go along the x-axis now, as you go along the x-axis, my y values are increasing, and they're increasing up until I get to negative 1. So increasing from negative infinity to negative 1. Then all of a sudden, from negative 1 to infinity, my y values are decreasing from negative 1 to infinity. Okay? And remember, this is a maximum point, so maximum y value is 7. Okay, so I think that's going to take care of this lesson. So in this part, the functions were written in general form, so you had to use the vertex formula to get the vertex. Whereas in the previous lesson, or 2 lessons ago, the quadratic function was written in standard form or vertex form. Okay, so there are 2 different forms you have to be aware of. Okay, so that takes care of this.